Hi there once again and welcome to another Expresso mechanic tutorial, and in this one we're going to be looking at creating one of these little beauties, which is a Geneva Movement, a superb piece of engineering and something that I greatly admire. It'll mostly be Expresso, but we'll also do a little bit of Python that we'll create in the Python node. So without further ado, let's open a new project and see if we can make this happen. Because this is quite precision engineered, what I'm going to do, I'm going to show you how to develop this from the ground up. So I'm going to actually model this one and break with tradition, because I don't normally do modelling, but I will here. So I'm going to grab a cylinder. I'm going to give this a radius of 200, a height of 25, a single height segment and 6 rotation segments. And what we're creating here is what's known as the index plate, and this particular one will have 6 indexes. You can make these plates with virtually any number of indexes, but for our purposes here I think 6 will be fine. So let's continue, and I'll grab another cylinder. Give this a radius of 75, a height of 30, a single height segment and 60 this time rotation segments. Okay, I'm going to change the display to Garrett lines, or have we got it in Garrett lines? Yeah, we're in Garrett lines. I think we're still set up with isopalms though, so we need to change to wireframe. Yep, that's better. Right, moving on from here, we'll throw this into a cloner, change it to a radial and give it a count of 6 and a radius of 200. Now these are not quite in the right place. If we go to our top view and just look at everything, these are not quite in the right place. We need them on the corners here, not on the actual flat edges. So in order to do that, we'll just rotate the cloner by 30 degrees in the heading, and now that's all in the right place. We'll just stay in the top view and I'll grab a cube, and what I'll do here is change its X value to 20. Its Y I'm going to make 50 because I'm going to be adding fillets in a minute, and 140 will be fine for that. In fact, I'll make it 150. That'll be fine for the Z. The fillets I'm going to make 10 centimeters, and I'm going to have 5 fillet subdivisions, and that'll be nice. From there we just grab another cloner, throw that into it and do the same as we did before. So a radial cloner with 6 for the count, and this time a radius of 140, and that should look great. And it's taking shape, and you can obviously, I mean, what we're going to do, we're going to use these objects as in a boule and cut them out of the plate there. To finish it off, we just need another cylinder. We'll give this a radius of 40, a height of 30, once again a single height segment, and 60 in the rotation segments. And they're all the elements that we need to create the plate there. So what I'm going to do next is bring this cylinder up to the top, which is the plate itself, and I'm going to call this index so that we don't get confused. Before I go any further, I'm going to copy my cloners, just as a precaution in case we needed to do any work. It's you know, go back on anything and do any work. That's why they're there. So I'll just make them disappear in both the editor and the renderer so that we don't get any problems with them. But they're there in reserve if we need them. And then these first 2 cloners I'm going to make editable. Open them up, remove the cylinders, remove the cubes, and then delete the cloners there. Get rid of those because we don't need those anymore. Select all of these objects, make them editable, come up to Mesh, Conversion, connect objects and delete, and that's great. That's done the first bit. I'm also going to make the index itself editable as well. Okay, so moving on from here, I'm going to hold down the Alt key on my Mac and select a bool. That throws the index in, and then all we've got to do is put the cylinder 1 object in there, and you can see that we're actually getting the object that we want. A very important stage here is to create single object. I'm doing that because what I'm going to do is connect these two. So I'm going to do the same thing again, mesh, conversion, connect objects and delete. That hasn't worked, so I'll tell you what we'll do. We'll do this first. We'll make that editable. And that's actually better. I didn't need to do that. Just making the bool editable has done the job for me. And I can then call the bool index. Now, I'm going to add a bevel deformer to the index plate, and the reason I've made it one object is because the bevel deformer wouldn't work had I not done so. So I'll just drop that on there. And now you can see that that bevel deformer has already started doing its work. We're going to just give it 3 subdivisions. We've got a bit of an artifact there, but that's easily corrected. We just need to come down to corner n-gons here and say, don't want patch there, just come down to corner n-gons, check this box, and they disappear. And it should be good, and everything looks as if it's fine now. So we have a very beautiful index plate. Okie dokie, that's nice. One thing we don't need, we don't need this selection here. No need for that at all. So we'll just get rid of that. Quick render. Yeah, and it's looking pretty good. I'm quite liking that. Okay, we'll leave that as it is. I mean, if you want to play around with the Phong shading and things like that, you can try and have a go with that if you wish to. But for our purposes here, I'm going to leave that as it is. I'm not going to do any more with that. So I've got an index plate made. The next thing I need to think about is a cam. So I'm going to make another cylinder. I'll just go into my top view. A radius of 75 for this one. And a height of 25 so that it matches up. And then all we need, 4 height segments can become 1, and then 60 in the rotation segments once again. And all I'm going to do is move this to 200 in the X, and it will line up perfectly with what we've got there. So that's already looking very nice. The next port of call is to hold down the command key and copy this to get another cylinder. Move this one back to 125, which places it on the edge of our previous cylinder there. And then I'm going to switch to my top view, make this editable. Select my scale tool. And I can just zoom in a little bit because we want to get away from this center point. That's why, because you might put a spindle through there. I'm not going to actually. I'm going to do it in a different way, but you might do. But that's why I'm doing that. So we just get a cutout, but we don't want too much of a cutout. Place that there. And then again, it's a simple case of selecting the top cylinder, holding down the Alt key, grabbing a bool and dropping that into there. Now, the reason that hasn't cut out is because this cylinder here needs to be slightly thicker. And if we do that, straight away we get the cutout. And now we've created the cam. And as before, what I'm going to do, I'm going to make this one editable, select the bool, and create single object once again. And then all I need to do is make my bool editable, and we're ready, and we've got our cam made. And then all we need to do is, as we did before, add a bevel deformer and just drop it into the cam. And we've got a cam set up, and we can just say 3 into subdivision, and Bob is our uncle. Lovely. Looking really nice. So now if we rotate the cam, we're going to get it passing through perfectly, and it's going to do the job fine. What we'll do is another check actually before we go any further, because it would be a bit embarrassing if this was wrong. Let's just do 30 degrees there, and you can see that's fine. If we go into the top view, there's enough clearance there. That's going to be working fine. Okay. Lovely. Right, so let's do a quick render, because there's a couple of sort of artifacts creeping in there, but I don't think you'll see them when you render. But if we do, and we can see something there, can't we? What we might need to do is just level everything up again. Just take that back to 0 while I think about it. And this cam, what I'll do, I'll rotate that 180 degrees. And we'll just have a quick look at it from this side and just see what's going on there. Let's have a go. Yeah, I mean, there's a bit of an artifact creeping in there. That's probably the fog shading. Probably if we just go into garage shading there, yeah, we can see it there. Let's do a little bit of an adjustment and see if we can make any difference to it. Can probably do a little bit of work down to a bit better there. Let's just see what we're getting there. Yeah, I mean, that's better. It's still not 100% perfect, and you might be lucky to actually get it 100% perfect. But for our purposes here, I mean, this is not sort of a texturing. It's not a texturing tutorial, and for our purposes here, I think I'm going to leave it at that. I mean, those two artifacts are still in there, but you don't see them when you render, so I'm not too worried about that for our purposes here. Okay, so I've got my cam and I've got my index ready. The next thing I'm going to do is create what I'm going to call the driver. So that's another cylinder, and its radius wants to be 125, and a height I'm going to give it 10. Again, I'm going to just say one height segment and 60 in the rotation segments, and then I'm going to move that 200 along the X so that it's perfectly aligned with the cam, and then it just needs to be dropped down to minus 17.5 in the Y, and it will line up with everything perfectly. So that's good. That's those two things sorted out, and the cam can actually be grouped into the driver. And on the driver, I'm not going to make that visible. What I'm going to do on the caps, I'm simply going to put a fillet on it. I'm going to make it 1 centimetre to match up with everything else, and leave the fillet segments at 3, and that'll do nicely for that. I think that should look okay. One more thing that we need to do in order to make this mechanism work is produce a cam follower. So we'll call this the follower and start working on it. Its radius I'm going to make 9.5 because obviously these slots are 20 wide, so that's going to give us a bit of clearance by doing that. And then the height, I'm going to make it 25 so that it matches up with everything else. One height segment, and again just go 60 in the rotation segments. The caps, we can put a fillet on it, and again just 1. That should do nicely. And then all I've got to do is move that 300 on the X, and it will be in the correct place. Call that the driver. And then all I've got to do is drop that cam follower into the driver, and then when we rotate this, we should find that the cam follower matches up perfectly well with the slot. And if we just go into the top view, we can see that that's the case. So that's working really nicely. If we just put that back to 0, so that's all working very, very well. And then I suppose to finish it off, we could put a center like spindle that it rotates around on there. So if we just get another cylinder, we'll make that 40, because that's what it is anyway, isn't it? It was 40 in there, that's fine. Make it, I don't know, 50 in height, so it's a little bit proud of there. And then a single height segment, 60 rotation segments, and in our caps the same deal as before, just a single centimetre for the fillet radius. I'm not going to do any more modelling with that because I don't think it's really worth it. It's doing the job and it looks fine and dandy to me, so that's all looking very nice. So if we just take a quick render of that, yeah, everything looks quite pretty, doesn't it? It's all looking very nice. That essentially completes the first part of the tutorial and goes into how we actually model this thing and get it to actually marry up and make it so that it's going to be working perfectly well. Great, we'll move on from here, get our Expresso editor open, and then we'll start looking at how we're going to make this thing move and operate properly. Right, before we start, let's just switch to our top view and take a look at what we're trying to achieve here. We've got the driver wheel here. Now, every time this driver wheel rotates to this position, the cam follower here has got to start turning the index plate. That's pretty obvious. So it's going to turn the index plate until it reaches this position. So we can say that the cam follower needs to be turning the index plate between 120 degrees if we look down here, and then if we go to here, it's going to be 240 degrees. So between those 2 points, the index plate has got to be rotated. So if we take the index plate, how much have we got to rotate it? Well, it's going to rotate through one index, so it will be rotating that much, which is going to be 60 degrees. Now, obviously it's minus 60 because it's going in a negative direction, but it's going to be 60 degrees. So every time that condition is satisfied, 120 degrees here, at 120 degrees, the index plate must rotate through 60 degrees over 120 degrees of the driver wheel turning, because obviously 120 plus 120 is 240. So that's what we're about. That's what we've got to try and achieve with our Expresso expression. Right, let's have a look and see how we're going to go about doing that. We'll just set everything back to 0. Go into our standard view. Right, okay then. First thing to do, get a null. Name it Expresso, and we'll put a programming Expresso tag on there. The first thing I need to bring in is the driver. I'll bring that in, and I'm also going to bring in the index itself because we're going to need both of these, and I'm going to set this to coordinates rotation H, and the same for the index. Okay, just need those two set up. Moving on from here, I'll get 2 degree nodes because I like to work in degrees. If you don't like degrees and you're happy to work with radians, then you don't need these 2 nodes, so you can skip them. But I'm not Mr. Maths, as I've said at other times. I'm really not the greatest mathematician in the world, so I like to work with degrees. And so we've got our function set from radians to degrees, so all we need to do is plumb these 2 into the inputs there. Now I'm just going to work with the driver for the moment because I'm going to set that part of the expression up first. So let's have a look at where we are. So the thing I need, firstly, 2 compare nodes. I'm just going to bring those in and connect those together, and these I'm going to set their functions up and they're going to be slightly different. So we've said that we wanted to work between 120 degrees and 240 degrees, so our first compare, the function needs to be set up to greater than or equal to, and it's going to be 120. And then, oops, let's just see those again, and then our second compare we're going to set up to less than or equal to 240. So when we're between 120 and 240 degrees, then we're going to be wanting to do something. So the next thing we need to do to actually check that and make sure that that's the case is to get a bool. And we can leave the function at and, that's absolutely what we want it to be. Plumb these 2 in, and that will enable us to make that particular check. So if the output of this bool is true, we're definitely rotating between 120 and 240 degrees. That's what our driver is going to be doing. So that's absolutely fine. Let's get a general, we'll go down to a result and we'll just make sure that we're doing exactly that. So plumb that one in there. Get a hold of our driver and begin rotating. Oops, not in every direction, just in the heading. Okay. I'll tell you what I'll also do so that we can see this in real time. I'll select Calculate Animation Refresh. Okay, let's have a go. Let's see what we've got. So yep, we're starting to get there. We've got an output of 1 there. Let's see what we get. Go around to here, just outside. We should find that we get 0. So that's absolutely fine. That proves that we're doing the right thing and we're going to be working between those two values. That's absolutely brilliant. So that completes the first little part of our expression. Moving on from here, what I'm going to do is bring in a math node. And this will be a modulo. And I'll set the input 2 to 360. And then plumb the degree into the top input there. I'll explain a bit more about this when we get a little bit further in. My next node that I'm going to be needing is going to be our old friend, the range mapper. Such a useful node. And I'm going to plumb the modulo into the input there. Now, all we're doing really is counting, well, we're looking at this, we're moduloing 360, so obviously we're looking at 360 degrees. Every time there's a rotation, we're going to get a 0 at the output here. But the modulo is actually used both here and also a little bit later in the expression. But what we're interested in here, though, is when we're between our input values of 120 and 240 degrees. They're the values that we're interested in coming out of the modulo for the range mapper. Now, we said that we would operate between those two values with the drive wheel. Now, the index, we said that we were going to go from 0 to minus 60 degrees. So they're the values that we're going to be needing to use when we need to rotate the index plate. That's what the range mapper's function is going to be here. Now we also need to set the spline up, and we need to clamp upper and lower. For the moment, I'm not going to set the spline up completely. We're just going to put these couple of points in here and then set that like that. And I'm going to leave that like that for the minute. There will be some more work to do on it, but we'll get there a little bit later. Next thing I need is a Python node. So I'm going to bring one of those in. The inputs here, they're both real values, and so is the output, so I can leave them as they are, and I just need another, well, it's another float, but it is a real value. It's a little bit confusing, but that's what we need there. And I'm just going to rename all of these. So the first one, I'm going to call this one trigger. The second input, I'm going to call check. And the third is a bit of a mouthful, but that's going to be IP for index plate ROT underscore H, so index plate rotation H. At the output, this is going to be even more of a mouthful. I'm going to call this IP current rotation H. So that's the inputs and outputs set up. If we just open the Python editor, what I'm going to do here, I'm going to put all the code in, wire up the Python node, and then I'll explain exactly what I've done and why I'm doing it. So first thing I'm going to say is global ROT for rotation, and I'm going to say if check is equal to 0, rot is equal to and open an empty list effectively. If check is equal to 1, if len ROT is less than 1, ROT dot append index plate rotation H. And then if trigger is equal to 1, if len rot is greater than 0, IP current rot H is equal to ROT open close 0. And then I can simply say else IP current rot H is equal to IP rot H. And that's all the code we need to do. Moving on from here, what I'll do is set up the various connections here. So the output of our bool is going to go to the trigger. The output of the modulo here is going to go in the check. And finally, the output of the degree node here is going into rotation H. So what are we doing here? Well, I set up this global rotation list, which is exactly what it is. And the reason I've done that is because I want to grab in the index value here, or the rotation H value of the index plate. And I want to turn what is potentially a variable into a constant. And that's what I'm doing here. But the way we're going to do this, the way it works, so if the check is 0, now the check is coming from the modulo here, and that will be 0 when our drive wheel, or driver wheel here, is at 0 degrees in the rotation H, which it is at the moment. So at the moment that will be outputting a 0. So when the check is 0, at this point I want to clear this list out. I want it to be a null list. Okay, at that point. However, we then come down to here and say, well, if the check is 1, and that means that if our driver wheel is at 1 degree, so if we're getting a 1 taken out of here or being produced at the output here, then what we need to do is check the length of our rotation list. And provided there's nothing in it, so if it's less than 1, if the length of it is less than 1, it's got nothing in it, it's a null list, then we can append that rotation list. We can actually add the IP rotation H, which, as we know, is the rotation value of our index plate, which is here. So we take that in and we populate the list with that value. And that grabs that value in and it makes it a constant, because that list will only ever contain that one particular value. It can't contain anything else, because we only populate it if its length is less than 1. Once it's 1, we don't touch it again. So that gives us a constant value. Now we then move on to the trigger. So if the trigger, and we know that the trigger is the output of the bool here, and that only works, of course, once the drive wheel is between a value of 120 and 240 degrees. So when that output is true and we're between those two values, then we check the length of our rotation, and if it's greater than 0, so if it's got a value in it, then we output that value at the output stage here. So IP current rotation H will be equal to that value at that point between those two. Now at all other times we simply output the value here. So we can output it as a variable at the rest of the time. It doesn't matter, because it will, well, it will still be a constant, of course, because it will be fixed in place when the wheel is rotating here. It's locked in place. But we can treat it as a variable at that particular time. If we were to treat it as a variable at all times, the problem would be that we'd get exponential growth, and we'd find that that wheel would just spin round as, you know, until it reached an infinitely large number. So we can't do that. We need to grab its value, put it into a list to turn it into a constant, and then we need to output it at this output here when we're between these two values, because at that point we're going to be moving this wheel, and we want to add a value of between 0 and minus 60 degrees to the current rotation value. So we've got to treat it as a constant for that reason, because if we took it as a variable, we'd get exponential growth and the rotation could increase to an infinite number, and crash Cinema 4D. So we've got to be careful with that. And that's why we do it the way we've done it. I hope that's clear. So moving on from here, what we need is an addition node. So we'll come down to Math and grab one of those. So we've got our node there. Now, what do we need to add to what? Well, quite simply, when our wheel has reached 120 degrees and needs to move our index plate, we need to get the value of our range mapper, and we need to add that to the current value of our index plate's rotation H. So that's what we're adding to there. Okay. In order to get this to work, we need a logic condition. We'll bring that in here, just move this back a little bit, bring this over. And this is going to be driven by the bool. So between the values of 120 degrees and 240 degrees, we need to switch to this second input here, and this is what we need to be using. At all other times, we can just take the output from the Python node, and that will give us, well, it's going to give us what we're getting from the degree node, actually. I mean, technically speaking, I suppose we could go from the degree node, but we'll go from the Python. It's just, it makes sense to do that at all other times, because we've got it all set up in here anyway with the else. So that's all set up, so that's okay. And then finally, well, it's not really final because we're not finished yet. We've got a bit more work to do actually, but we'll get, for now, we need a couple more nodes to actually get something to work. So let's just get a degree node, set that up at the output of the condition there, and then just move that out the way and set degree to radians, and then bring in the index and set that to coordinates rotation H, and plumb in the degree node into the input there. Now, all things being fair, we should get some motion. So let's just run things. What we'll do, I'll just get rid of that for a mo. I've got my driver selected, so what I'll do is come into the coordinates here. Now, my timeline is currently just 90. I'll tell you what I'll do, 1800 frames. There's a lot of frames, but I'll do 1800. I'll set that there. I don't want those. Just get rid of those. I just want that one, and that one I don't need. I just want that one. Okay, so move to the end of the timeline, and then I'm going to say 360. I'll just go for times 50, so we'll do 50 of those. 18,000, that's absolutely fine, and then record that. What I'll also do is go into my animation F curve and remove, or rather make it into a linear time rather than an easy out curve. That's fine. So that's got that set up. Right, the moment of truth. Let's see if we get anything. And we do. We're starting to get it, but you can see there's a bit of an issue with it. It's not perfect, not by a long way yet, so there's still a bit more work to do. So let's go back to 0. Let's just get our plate back to 0, and let's see what we need to do. Well, for a start, I said that there was some more work to do within the range mapper. And the essential thing here is that we need to adjust the curve. I mean, there's going to be people out there who are going to say, oh, you know, you should do this with trigonometry. You shouldn't really do it this way. Well, yeah, that's great if you know that sort of stuff. If you're a real mathematical wizard, then fine. Yeah, do it trigonometrically. And if you want to reach out to me and teach me how to do it so that I can do another tutorial on this based around trigonometric functions and all that kind of stuff, then great, reach out to me. But, you know, I'm not the best mathematician in the world, so I tend to do it like this. Well, what we've got to do is, if we twirl this down here, what we've got to do here is simply say in the tangent, we're going to set this to 0.375. 0.375, not 375. And this one to minus 0.375. Now I know that that's a good setting for this to work. So if we go into our top view, let's just have a quick look, see what we've got. So if we step through, we can see that that's working really nicely. Now, it's not 100% correct, is it? Not 100%. So let's just check to see what's coming out of some of these nodes. We'll just have a quick check, see what's coming out of the Python node. Actually, that's the most important one. So we get a result node and we plumb this in here. Let's see what we've got there. Right, so we've got minus 59.4, and that probably means that this is minus 59.42. So let's have a quick look. Yes, it is. So we didn't quite get what we wanted, and the reason for that is because if we just check, let's just check the range mapper, just check, see what's coming out of there. This should currently be minus 60, and it is, so that's correct. Well, then we've got no problems there. So why didn't this addition here, why didn't this add the whole of the minus 60 to this here? Well, I'm not exactly sure, to be quite honest, why that does that, but there's definitely some kind of accumulation of error going on in the maths there, and I don't understand fully why this happens. But there is a fix for it that I've found that I can use, and that's in the Python node again. What I can do, I can say import math. So I'm importing the math module from Python. And that contains some important functions, two of which are floor and ceiling. And what we need to do is use the floor function. So we can say in here, math dot floor brackets rotation H for a start. And the floor function rounds things down to the nearest whole number. So even if you get 9.9, it will round that down to 9. It always rounds down no matter what the sort of floating value is, what the fractional value is. Ceiling, on the other hand, goes the other way. So if you've got 9.1 and you put ceiling, you use math ceiling or ceil, if you put that in there, it will round 9.1 up to 10. So it always rounds up to the nearest whole number. So they're useful functions. Now, the only other thing we need to do is come down to here and do the same thing. If we say math dot floor rotation H in there, this should help us. Let's see what happens if we just execute that. So let's do, we'll plumb that into there. It'll be, see, at the moment it's saying minus 60 now. So that's helped us. That's actually helped us. And you can see it's already corrected this. So if we get our drive wheel now, go back to 0, and we will get our index value here. Our index should at the moment be minus 60. We'll put that back to 0. Right, let's see what happens when we make this move now. And it's perfectly good now. So now we've got minus 60 in there, and that's exactly what we wanted. So that's corrected that bit of that problem. Let's just do a little bit of a test here. What I'll do, if we go back to 0, our wheel is back to 0, put our index value or our index plate back to 0. What I'm going to do, I'm just going to get a sphere and I'm going to make it a lot smaller. Make it, say, 10 in the radius. Just bring it up to there, bring it along to here. Get my sphere, drop that down. So it's just like a sort of little marker that goes in there. And then I'm going to drop that into my index. So now when the index moves, we've got a little marker there that shows us what's going on. So let's just run the timeline again. So we're only getting one movement, and that's a bit strange. So why are we only getting one movement? We've got modulo 360 in there, haven't we? So that's fine. And we've got the compares set up. So therefore we should get another movement. Now let's have a look at the Python. What have we got going on in the Python? Everything should be okay in here. Let's have a quick look, just to make sure I haven't done anything wrong. No, that's absolutely fine. That's absolutely fine. No, it's all looking good in there. It doesn't look as if there's anything in there that's not doing what it should do. So that should actually be working. Well, if it's not in the Python, then the next place to go is the Expresso, and we'll have a check, see what's in there. Let's just get rid of that. So have a quick look. Okay. Yeah, I've made a schoolboy error. The reason it isn't working is because we need to plumb the modulo into these two. Yeah, they've got to be plumbed into there because obviously we're looking at 360 degrees. And as soon as we complete C at 360 degrees, we go back to 0. So this number that comes out of the modulo can never be beyond 360. And that's important because these, of course, are looking at greater than or equal to 120, less than or equal to 240. So if we didn't put the modulo in there, we just keep accumulating and we'll get beyond those two values and they'll never be true. They'll never be able to make this build true. And that's why that didn't work properly. Right, so let's see what happens now when we return to 0 and play the timeline. Yep, we've got it working. However, there's likely to be another problem further down the line. And what I'm going to do, I'm going to pause the video here and then I'll come back to you when the error occurs and I'll let you see what's happened. Okay. So just over 1,000 frames, you can see what's happened here. We've got another error that's crept in. And if we just get a result node and we plumb our rotation in there. Now you can see that we've got 1741 or minus 1741 degrees effectively coming out of there. So what we've got, we've still got this accumulation of error thing going on here, and it's pushed it over into, it's probably actually because obviously we've got the floor mathematics in there, that we've got the math function, the floor function in there. We've ended up with something like minus 1740.x frames, and then this has been rounded down to minus 1741. Well, it needs to be minus 1740 because there should always be a 0 on the end of this number. So we've got, as I say, it's an accumulation of error that occurs, and I'm really not sure why this happens. I can't explain it, but fortunately there is a way to fix it, and I'll show you that right now. We'll just rewind the timeline, set the index plate back to 0. Great, so we're ready for our next attempt. So what we need to do is come down to here. We just need to say logic compare. We compare this to, I'll tell you what though, before instead of doing it that way, what I could do is just get another modulo. If I just say a modulo there, and I'm going to try this. I don't know, I've not tried this way with this. I did it with a compare before. What I'm going to say is modulo minus 360. And then I'm just going to plumb that into here. Now let's see if this actually does work. So what I'm going to do, if I just get a result node and plumb that in there. I wouldn't normally use a compare and a condition, but I want to just see. So it's just sort of an idea of while I've been doing the tutorial. So I just want to see this if this works. So let's see what comes here. So that's minus 60. Yeah, that's perfectly fine. No reason to do it any other way. That's the better way of doing it, a more efficient way. Just use a second modulo. Right, so what I'll do again, I'll pause here and can then come back to you when the timeline reaches 1,000 frames, and we'll see if we fixed it. It should have done now. Yep. Yeah, no problem at all. That's working fine. Yeah, that's working perfectly well. I mean, obviously it's out of sync at the moment because of where I've stopped the video. But if we just take that back to 0, it should all be fine. But we can say with absolute certainty that that modulo has solved the problem and everything's working fine now. To quote Columbo, there's just one more thing. We'll bring in a time node. Not that one, I want a time node. And we'll also bring in a compare. We'll leave it at equal to 0 because that's what we need it to be. I'll get another condition and put it up here. So when the timeline is equal to 0, in other words, when we're at the start of the animation, what I want to do is reset my index plate's rotation H to 0. So I'll leave my input 3 of the condition at 0 and then plumb in the condition here into input 2. And then all I need to do is connect the output of the condition to the input of the degree node. And this will give us what we need to make that happen. So when our timeline is at 0, our index plate will be at a rotation value of 0 degrees. Let's just move that out of the way. And now if we play the timeline, if we stop it at any point and we reset to 0, everything returns to its initial rotation value. And that just finishes it off, I think, and just keeps it tidy. And we now have a very beautiful and fully functioning Geneva movement. I tried to find out who came up with this, but couldn't find a name, but it's a great piece of engineering, truly fantastic, so hats off to whoever it was. And that about wraps it up for this tutorial. So if you've enjoyed this one, please give it a thumbs up. And if you haven't already, then please subscribe to the channel. It's always good to get a few more subscribers. But anyway, that about does it. I'll see you very soon on the next tutorial.